Good morning, everyone. Here we have going to solve a begin method problem or penalty method problem by using the following LPP. Maximize z equals to 2x1 plus 3x2 subject to the constraints x1 plus x2 less than equal to 8, x1 plus 2x2 equals to 5, 2x1 plus x2 less than equal to 8 provided x1 greater than equal to 0 and x2 greater than equal to 0. How to solve? First, we have to put the above LPP in standard form by introducing slack variable or surplus variable if we need. Here, both have less than equal to sign and one is equal to sign. So, for less than equal to sign, we are introducing slack variables to first and third constraint x3 and x4. And again, we have the matrix in form 1 1 2 1 2 1, and for this variable we have 1 0 0 and 0 0 1, but unit matrix 0 1 0 is missing. For this one we have to introduce a artificial variable to the second constraints, and this is my artificial variable is x5. So the adjusted objective function, what is my objective function? Objective function is this one, maximize z equals to 2x1 plus 3x2. So now adjusted objective function is maximize z equals to 2x1 plus 3x2 plus 0 into x3, this is an slack variable, 0 into x4, this is an slack variable, and minus m into x5, this is an artificial variable. Now we have to make the simplex table. For simplex table, this is my table. We have to introduce CB, cost against basis, XB, this is solution vector, B right hand vector, and Y1 is the coefficient vector of x1, y2 coefficient vector of x2, y3 is coefficient vector of x3, and so on. So first we put the matrix in the table. First we put according to the matrix in the table. This is the matrix. First coefficients is 1 1 2. So first we are putting 1 1 2, then second 1 2 1. Coefficient of y3 1 0 0, y4 0 0 1, y5 0 1 0. Next we complete the right hand vector, that is 8 5 8. Next we fill up the cost values against the objective function, that is equal to coefficient of x1 x2 x3 x4 and x5. So the values are 2 3 0 0 minus m. Next we filled up the cost against basis. What are the bases? First basis is y3, so cost is 0. Next is 0 1 0, second basis, cost is minus m. Third basis is y4 0 0 1, so cost is 0. And against values of vector is first basis is y3, that is the next 3, then y5, that is the next 5, last is y4, that is an x4. Now calculate zj minus cj. How to calculate the zj minus cj values? We have to calculate, don't calculate this cell first. If all zj minus cj are greater than equal to 0, then we calculate this cell. First calculate this z1 minus c1 value. So 0 into 1 0 plus minus m into 1 minus m plus 0 into 2 is 0. So total we get here minus m minus cost, that is minus 2. So minus m minus 2. Next is 0 minus 2m plus 0. Total is minus 2m minus 3. Next is 0 into 1 plus minus m into 0 0 plus 0 into 0. Total value is 0. 0 minus 0 equals to 0. Next 0 into 0 minus m into 0 plus 0 into 1. Total value is 0. So Z4 minus C4 is 0. Similarly 0 into 0 0 minus m into 1 minus m plus 0 into 0 minus m plus m 0. So most negative zj minus cj is z2 minus c2 minus 2m minus 3. Minus 2m minus 3. Next, most negative, so this is an entered vector in the basis. So we have to depart someone. For departing vector we have to calculate the minimum ratio. Minimum ratio for what? We have to calculate the minimum ratio entering vector and right hand vector. So 8 divided by 1 equals to 8. 5 divided by 2 equals to 5 by 2, 2.5, and 8 divided by 1 equals to 8. So minimum value is 2.5, and corresponding vector x5 will depart from the basis. So what is the pivot element for which we get the minimum ratio, that is 2. Now in next table we have to make this 2 in converted to 1. That's why we are throughout divided this row by 1, so that we are getting 5 by 2 half, 2 by 2 1, 0 0. And what is the next calculation? We have to make this value 0 and this value 0, and for that we have to calculate accordingly. This value is 1, so to make it this one 0, we just subtract from this row to new row, and after calculation we are getting all these values after this. And since departing vector is x5, so, and this is an artificial vector, so in next column we never calculate this column, so we cross through this column. Okay, again for this is on pivotal, so we have to make this value 0 and according to calculate this one, so we just subtract from this row to new row, and we are getting these values. So now this is my new simplex table, and forward x5 is a departing vector, and after that entering vector was y2, that is an x2, so x2 is coming here. How should we understand this one? My first basis is 1 0 0, that is x3, second basis is 0 1 0, that is x2, and third basis is 0 0 1, that is an x5, and corresponding cost of x3 is 0, cost of x2 is 3, and cost of x5 is 0. Again calculate Zj minus Cj. How to calculate Zj minus Cj? All of you know that 0 into half 0 plus 3 by 2 plus 0, so 3 by 2 minus 2 equals to minus half. Next 0 into 0 plus 3 into 1 3 plus 0, total value 3 minus 3 0. Next is 0 into 1 0, 3 into 0 0 plus 0 into 0, so total value 0 minus 0 equals to 0. Similarly this value is also 0. The most negative is only one value, that is minus half. So next we have to, this is an entering vector, that is y1 is an entering vector. Then we have to make minimum ratio to find the departing vector. So what are the minimum ratio? 11 by 2 by half, 5 by 2 by half, 11 by 2 by 3. That is the minimum ratios, and this ratio is minimum, so corresponding vector will depart from the basis. Now this is a pivotal element, so you have to make this one by multiplying it 2 by 3. Throughout we are multiplying this row 2 by 3 and we are getting these values, and we have to make this value 0 and this value 0. So from this row we are subtracting this new row by multiplying by half, and also from this row subtracting the new row multiplying by half, so that we are getting this new row. And now this we are getting 1 0 0 is the first basis, 0 1 0 second basis, and 0 0 1 third basis. And according to that we are writing first x3, then x2, then x1, and corresponding cost are 0 3 and 2, 0 3 and 2. So now after calculating the Zj minus Cj accordingly, we are calculating Zj minus Cj accordingly like that. 0 into 0 0, 3 into 0 0 plus 2 into 1 minus 2 equals to 0. Similarly 0 into 0 plus 3 into 1 plus 2 into 0 is 3, 3 minus 3 is 0. Similarly this value is 0 and this is 1 by 3. So now all Zj minus Cj are greater than equal to 0. Next we calculate this value. This value we are calculating. How to calculate? 0 into 11 by 3 0 plus 3 into 2 by 3, so 2, and 2 into 11 by 3 is 22 by 3, so 2 plus 22 by 3 is 28 by 3. So this is my Z max value. Okay, and all Zj minus Cj is greater than equal to 0, that is positive. So we are getting the optimal solution, and optimal solution is x1 equals to 11 by 3, x2 equals to 2 by 3, and x3 is not an original variable, so we are not consider this value, and z max equals to 28 by 3. So this is the required answer. Thank you.